Let's get started then. Good morning, everyone. Thanks for joining this webinar. And thanks to ACCE, American College of Clinical Engineering, for hosting this webinar. And happy HTM week. I hope all of you are doing safe and healthy. Let's get started. Shankar?
Thank you, Priya. This is Shankar. I'm the CEO of Asimily. And along with me is Patrick, who's from Methodist Le Bonheur in Memphis. And he's a certified clinical engineer. So today we'll cover medical device cybersecurity management at Methodist Le Bonheur. We'll see some of the challenges faced in managing these devices, including around vulnerability management, considering the fact that many of the devices in healthcare are legacy devices. So we'll see the challenges with vulnerability management, how it's being done, and how Methodist Le Bonheur has balanced costs and at the same time has collaborated and coordinated with their IT teams. And finally, we'll discuss their future plans and how they plan to move forward. So a couple of quick lines about Asimily. We are a venture-backed company focused exclusively on healthcare and working with health systems across the country on kind of medical device lifecycle management as well as connected devices in healthcare. We have members across healthcare technology management, cybersecurity, networking, and data analytics. We solve for a number of use cases across inventory, cybersecurity, and operational, and we integrate with a number of different systems. So up over to you, Patrick, on Methodist.
Hi, good morning. My name is Patrick Duncan, and I work for Methodist Le Bonheur Healthcare in Memphis, Tennessee. We are a 6-hospital system with about 1,200 licensed beds, and at the end of the year, we will have 8 hospitals and around 2,400 beds. We have a little over 31,000 medical devices in our CMMS database, and we're affiliated with the University of Tennessee. Steve Jobs received his liver transplant at our university hospital in 2009. Can I get the next slide, please?
Yes. So one quick note before Patrick continues. For anyone who has questions, please type it in the Q&A box so that we can look at it and we can address it either during the presentation or at the end. Okay. Thanks, Patrick. Go ahead.
Thank you. We started working with spreadsheets, and I had a good working inventory of our imaging devices, but it was a bit hit and miss on all of our other equipment. I had a lot of missing data, and some of the data I had was just simply wrong. So at first, we began trying to collect all the basic device parameters manually, things like manufacturer, device type, model, operating system, and so on. We collected these using boots on the ground, mostly my boots. I use the MDS2 documents a lot, as well as the manufacturer's installation documents. And occasionally, I'd use Wireshark to try to determine which ports and protocols were being used. But I really had no way to determine if my medical devices were acting strangely on the network. We realized right away that we needed to automate the collection process, so we started looking at some options and ways to quantify the costs. Next slide, please. We performed several time studies, and we even had some vendors provide quotes to what they would charge to manually gather some of this information for us. After a while, we estimated it would take 6 engineers almost a year to gather all the information, and still we would not have the really quality information we needed, like ports and protocols or the SBOM, things like that. And, as you know, taking inventory is really only the first part of this process. So we would still need to identify all of our vulnerabilities, anomalies, and all the forensic work that's involved daily. So we knew this was going to be a very expensive and time-consuming process, so we ruled out manual collection really early on. Next slide, please. When I was collecting information manually, I planned to work really with our IT department to help fill in the holes of my inventory. They use tools like Rapid7, which scan the network to identify devices, but these tools use active scanning techniques. So before I set those loose on my medical devices, I wanted to do some testing in my lab. So I set up a small network with 4 physiological monitors that were connected to simulators. And we started running Rapid7 scans over a series of weeks. So every night we would set a scan, starting off really gentle and then let it run overnight and come back the next morning and check things. We gradually increased to really highly invasive scans. And one morning I came in and all of my alarm monitors were in asystole alarms. It turns out the scan had changed the gain of the ECG monitor. So at that point, even though, you know, it was a highly invasive scan, I doubt if we would use something like that on the network. We still rolled out, just because of human error, using active scanning on our medical equipment. So we looked at several products, and all of them honestly were good tools, but most of them seemed to be network discovery tools that also worked with medical equipment. We really were looking for something that was designed specifically for medical devices. So our evaluation had a lot of, several factors, but most important to me were that it used passive scanning and that it incorporated the MDS2 document. Next slide, please. So we went with Asimily, and it was really a smooth process. We install a collector at each of our hospitals. All the data is de-identified data, by the way, is sent to the cloud. There's no PHI leaving the network. And we access all this data through a web portal. And right away, I had a lot of insight. It turns out I had 7,500 medical devices on the network. So that's about 24% of our medical devices are connected. And about 59% of connected devices were wireless. So I wanted to point out that Asimily has been great at identifying my devices. So far, my detection rate has been above 99%. And maybe in the Q&A, you can talk to Shankar about the magic on how that works, because it's a bit of a mystery to me. But now I have information on every connected device. I have information like manufacturer, device type, model, operating system, software version, network information, and things like that. But then I also have reports and protocols that are used, the utilization of the device, network topology maps, and some very cool cybersecurity analytic tools. So we share the portal with our IT department, and they use it for network troubleshooting and also to help them with managing IoT and building devices that may fall through the cracks of their systems. Next slide, please. So this is a screenshot showing some of the columns that you can query when you're trying to do a data export. At my last count, there were 52 columns. It's a lot of data at your fingers. It's divided into 3 sections. The first section is a device parameter section where you can select things like manufacturer, model, device type, MAC address, and so on. The second section is an IT parameter section, and you can select IP, operating system, host name, VLAN, ports used, wireless parameters, things like that. The last section is really handy. It's a risk, impact, and anomaly section. And here you can select your risk and anomaly scores, likelihood scores. You can find your high-risk CVEs, any recall information, and your patient and business impact. So a lot of really handy information there. For example, I could do a query like, show me every imaging device that's running Windows XP, or any of my infusion pumps on the wrong SSID, things like that. I just wanted to point out, though, that it's very easy to find what you're looking for. So I'm going to hand the next few slides over to Shankar, and I'll be back in a minute.
Thanks, Patrick. So let's move to vulnerability management. So the next 2 or 3 slides that I'm going to talk about really talks about how we do vulnerability management at not just at Methodist, but also at every other site that we are in. So one of the key tenets when we started the company was, look, healthcare is different from IT. Medical devices and IoT devices, specifically medical, are very different from your IT workstations and servers. Everyone in the call is aware of that. And one of the things about medical devices is there's a lot of legacy in there. There's Windows XP, there's Windows 7. Most of the devices are not patched. And so if you go and try and do the same thing as IT, it's going to be a disaster where you're just trying to patch all devices in IT. You can't do that because the patches are not available in most cases. And in many cases, you really don't need it, because the real part is not all devices have the same risk in healthcare. You might have devices which have running legacy operating systems, devices which are the same model, manufacturer, operating system, software version, yet the risk could be different. And so whether an unpatched vulnerability is a risk in your environment, that means is it a high risk and is it a high impact, depends on a number of factors. It depends on whether the vulnerability is exploitable. So what that means is you might have a vulnerability on a device, but how easy is it to exploit that vulnerability? Can an attacker exploit it without much effort based on how the device is connected? Or can an attacker exploit that vulnerability by traversing your network with a lot of difficulty? So how easy is it to really get to the vulnerability and exploit it? The second part of it is what is the impact once the attacker exploits that vulnerability? Is it going to be a high patient impact? Is he going to be able to steal data from the device? Or is he or she going to be able to use the device as a beachhead and then move on to other devices and steal data? And then what is the operational impact of that vulnerability in terms of if the device were to go down, then what is going to be the operational impact? Are you going to have to go lease a new device right away? What is going to be, our patient going to be sitting in the waiting room because the device is not available? All of that factors into the impact. Then you have to look at how the device is connected. Every device is different in the way it's connected in your environment. There are two ultrasounds which are used. One could be used in an operating theater connected to a different machine, whereas the other could be in a different setting. They could be connected to a PAC server versus something could be connected to something else. So the way these devices are connected, the way these devices are configured are all different. And correspondingly, the security capabilities of the device are different. We have seen, different manufacturers have different kind of capabilities for the device. Plus, like Methodist and other places, the amount of security compensating controls that are added on top of it could also be different from a per device perspective. And then there are a lot of other factors that you've got to consider. I've just illustrated a few here. But when you account for all of this, you actually realize that some vulnerabilities are highly exploitable, and are high impact in that environment, right? So the same vulnerability and same device could be exploitable in one environment, but it could not be exploitable in another. So you can use these factors and determine which vulnerability and which device is exploitable and which ones are high impact. And then if they are high risk, high impact, because you started with the exploitability vector, you can provide a workaround that can mitigate the risk of a vulnerability without necessarily doing a patch, right? And that's what really takes your risk it really manages your risk. And one of the things when we do this is we have realized that the medical device cybersecurity problem is a manageable problem. I mean, in a lot of places, people talk about medical device cybersecurity as if the sky is falling. We don't believe that. We think because these devices are unique and because they're configured differently, the problem can be contained and the problem can be addressed and can be prioritized much more easily than what it's made out to be. So this is a simple snapshot. I mean, we just took a quick snapshot from Methodist, and similar examples are there at all sites. So all this shows is you have a Philips. This is just showing you the fact that I mentioned. These are Philips ultrasound IE33 machines. They're all running Windows XP Service Pack 3. Now, this is directly from the portal. They have anonymized a few columns. But you can see same manufacturer, same model, same operating system, same device type. And they also have the same software version, which is not shown here. And they all are similar anomalies, but yet the risks are different. Some of them are 6, some of them are 8. And so you can see that that's based on the way these devices might have been connected, configured, because all of the parameters are similar, like MDS2s and patient impact, in FDA class and so on. So there are some differing parameters in this that causes risk levels to be different. And then even the impacts here are same, but we have examples where the same manufacturer, model, device type, operating system, software version, can have different impacts as well based on the way they're connected in the environment, or based on their utilization, or based on where they are used in the healthcare environment. So this goes to the point that you have to look at it from a per device perspective rather than an aggregate basis. And you can have a legacy operating system, and yet the risk might be lower than even some of the others in the same class. And this is an example of a workaround, which I was mentioning. So you can obviously segment and block. And I've been in networking for more than 15 years now. And my experience is segmentation is a great tool to mitigate the risk in your environment. But one of the things with segmentation is it can be really hard to maintain segmentation over time. So when we talk about workarounds, we are obviously those options exist, but we are talking about things you can do on the network that can mitigate the risk of a vulnerability without doing a patch. So this is a simple example where we are saying, okay, there is a vulnerability in the kernel, and the way to mitigate the vulnerability is to prevent the device from, and we have done through our research, we have figured out that this vulnerability is exploitable by someone, using the fact that the device is browsing to a non-trusted website. So what we are, and this is just a high-level detail, but inside the portal, we give granular detail and say, you have to prevent the device from going to non-trusted domains. So a G, for example, can go to a G.com, but you don't expect an ultrasound to go to an Amazon.com. So by preventing it from going to non-trusted domains, you are mitigating the risk of this particular vulnerability, even though you might not be doing a patch. And that's what we are illustrating here. Now, the same approach might not work for some other vulnerability. Some other vulnerability might have a different exploit vector, you might need a different action. But by taking certain kinds of actions on the network, you are mitigating the exploit vectors for your high-risk, high-impact vulnerabilities. And by doing so, you're reducing the risk in your environment, even when you don't have a patch. And this also reduces your decommissioning costs, because you really don't have to go throw out that XP machine because it's end of life. Because you might have 5 years left on your service contract and you want to continue to use it. So Patrick, back to you. Patrick, can you hear me? Wait, let me just check. Patrick. Yeah, can you hear us?
Yes, I can hear you. Sorry for this difficulty. Hold on. I think Patrick has dialed in, so we have a bit of an issue here.
Hello,
Patrick,
can you hear me?
Yeah, we can hear you now.
Okay, good. Sorry about that, guys. So every device that connects to our network gets a risk and security assessment by our IT department. They evaluate the product and the company, and they look for things like, does PHI leave our network? Does the data leave the country? Is the data encrypted? What type of encryption do they use? And so on. Depending on their answers, the questions may get a little bit more invasive. Excuse me, I'm sorry. For priorities, I use a chart on the Asimily dashboard that identifies likelihood and impact by device type. And for patching, we all medical devices can't patch. The guy as exhibited in the NDS2 document. Well, we have our own Microsoft WSUS server that we use for patching management of all of our Windows-based medical devices. And the devices that we cannot patch, we take steps to harden the device by turning off unused ports and protocols. And again, just two. Using Asimily, it is very easy to find equipment at risk. For example, not long ago, there was a CVE released dealing with vulnerabilities associated with Microsoft for top service. I ran a very simple on all my devices for DP protocol. And then we decided to turn off those ones that weren't needed, or if it was needed, them to use NLA. High impact devices with unsupported operating systems will get a firewall appliance installed in front of them. And this firewall is used with source netting, and it essentially hides the device on the network. A good example is we have an MR system that has a Windows XP controller. We cannot patch it, and we cannot upgrade it. It works great, and it will cost several $1 million to replace. So we put this small firewall appliance in front of it, and our risk score went from over 10,000 down to 1. And we use these firewalls really until the equipment can be replaced. Next slide, please. I check daily for anomalies. Shankar, I'm on slide 14.
Yes, so I'm on slide 14. Yeah.
Thank you. So we look for any unexpected connections and try to determine if they're really necessary. I investigate every connection and attempt to try to stop it if it's not part of the normal device function. For example, I found users browsing the internet from X-ray controllers or even running iTunes on mid cameras. So we set policies to look for suspicious behavior. I had a problem not long ago where I kept seeing something trying to connect to several of my devices using FTP. It kept passing the same username and password on each device. And Asimily created a forensic analysis tool that allows me to actually see the source address of these IPs, the source IP address. And it turns out these were Rapid7 servers. So I had these devices added to our exclusion list. I'm going to again hand the next few slides over.
Okay, thanks, Patrick. So the next one really gives a snapshot about the anomaly and forensic analysis. So like Patrick explained, we have different kinds of anomalies that we discover on the network. And this is an example of known username password. This is actually drilling down into one kind of anomaly. So here you see an IP address, which we have masked out, the manufacturer, the device, the anomaly detail. The first discovered, the facility have again been masked out. So what you see here is just for this anomaly, where you see a known username password, it's a simple anomaly. You will see a manufacturer, the device type. The anomaly detail tells you the details of the anomaly, like what is the username and password that was used. And what we discovered is in some cases, the device is doing an FTP with a default username password. But in many other cases, as Patrick mentioned, the anomaly was not really coming from the device itself. It was actually the result of another device which is trying to log into this device with a default username password. And that's what you see in the source info. The source info identifies where is the source coming from. Sorry, and this is something that is very true in healthcare, that what seems straightforward and on the surface isn't always that evident. So here, like in this case, because the source info in some of these pointed to a Rapid7 scanner, in some cases you are not really, sorry, in some cases you're not really fixing the device itself, but in some cases you have to go and look at the root cause, which is some other source in your network, and really got to mitigate the action. And so this is part of the forensic analysis detail where the solution picks up where exactly the entire problem originates from. Is it from the device itself, or is it some other point in the network which is causing the device to look like it is misbehaving, whereas the problem is somewhere else, and then identify the source and gather information about them. And there are similar such examples that I don't have screenshots for, but I can quickly mention. Another example is, one of the things Patrick mentioned was the device is dialing out to an external IP, and you really want to know if the dial out to the external IP, you might realize that the device is dialing out to an external IP, and that IP is not desired in your network, and you might go block it. But you might want to go back, and your CISO or your heads might want to figure out, okay, the device is dialing out to an external IP, but what data did it transfer? How much data did it transfer? When did it transfer? And that is, again, going back and looking at the details, because you might have an IP you really didn't want the device to dial out to, but you want to understand the crux of the actual dial out and what really happened, so that you understand how severe that problem was in your environment before you take action. And so you have other kind of screenshots that you can leverage there to figure out how that is happening. And that kind of forensic analysis also helps you understand where you should spend your time and resources on. Yes, you have an anomaly, but how critical is it? What is the source of the problem? And what is the impact of that anomaly in your environment? So Asimily is able to provide that level of forensic analysis. And one of the snapshots is shown here, which Patrick and Methodist and all our other customers have also used successfully to identify, what is the exact level of effort they need when they see an issue popping up in their system. Patrick, back to you on policy management.
I have several policies set up. One in particular, it alerts me of any new medical device when it pops up on the network. Another one is any XP medical devices that are found on the network. We also look for medical devices that are connected USB to an imaging device. Mobile devices that are connected to imaging devices by USB. We're having a problem with people plugging their phones into systems and charging or what have you. We're trying to stop. A policy plan to implement soon would tell me when medical devices leave the facility. We're looking mainly for medical devices that connect to APs near an exit. And I'm going to be very excited when we get that working. Next slide, please. So this is an example of the policy management interface, and it is very easy to build a policy. And then basically it just sits out there and for any time that policy is violated. And when it is violated, you get a summary. It shows up on the summary dashboard in the assembly. Next slide, please. So some of the approaches we have taken are, I think, things like everybody else is doing. First, we started with securing our wireless devices. We have an SSID that is used only for medical devices. It uses good encryption and strong passwords. And we made sure that the SSID was not internet facing. When possible, we try to avoid Bluetooth options and take hardwired options if available. We've started a policy of blocking all unused USB plugs with a physical plug that plugs it just to stop the behavior of people plugging in their phones. We use Active Directory when we can. Again, you can find that information in the MDS2 document. Problems I've seen with using Active Directory is that you need to look out for inherited group policies. Sometimes unexpected things are pushed down, like power saving modes, screensaver timeouts, things like that. So if you are going to use directory, you want your own AD location with all the inheritance broken so that you can really have some control over that. Again, we always patch according to the MDS2 document, and we, if the manufacturer says you can't patch, we don't patch. I wanted to mention that some manufacturers handle patching differently. Some take the approach of, well, it's your equipment, do what you want. If you break it, you have to fix it. And some are more selective, and so you can only apply the patches that we approve. So you need to get familiar with your manufacturers. Most of them have portals that will give you this information based on the device type. If the MDS2 allows AV, we strongly encourage the use of antivirus, but you do need to follow the manufacturer's recommendations for exclusions. And my best advice is just to be vigilant. I mean, it's a constant battle every day. You got to look for new things. Next slide, please. So this slide demonstrates that with automation, it's a fraction of the cost as compared to manual. And to boot, I'm getting information that I simply just could not obtain manually. And I wanted to point out that as Asimily adds new features, our benefits of automation keep going up as compared to doing this manually. It's kind of hard to quantify these numbers, but it becomes obvious after a while. Next slide, please. So we've got some exciting things coming up. We're wrapping up the integration of Asimily with our CMMS software. This will generate work orders anytime an anomaly or vulnerability is detected, and it will allow for some enhanced tracking. I hope to one day incorporate some type of construction into the work. We do a plan to integrate Asimily with our Cisco ICE product to assist us with segmentation and access control lists. And Asimily does offer some very useful reports in imaging utilization and dose monitoring for imaging devices. And soon we hope to use Asimily for risk analysis at the procurement process by observing the procedures in the lab, observing the products, and see how they behave on the network. And there's a lot of operational use cases that are just very handy. Our plan is to use Asimily as a single unified view for all of our security and device management. And I just wanted to thank you again for your time today. I guess we're going to open up for any questions.
Thank you, Patrick. So with that, let's address any questions there are. I think a couple of questions have come. So let's go back to the questions. Okay. Okay, first of all, before we start the Q&A, happy HTM week. We should have probably started with that. I know this is a difficult time for all of us, and the work that all of you guys are doing at the forefront is, truly remarkable and great work. So thank you again for everything that you guys have done. So thanks for that. So, we can take a couple of questions, and then, if we have time at the end, we can also show you a quick snapshot of the product. So we'll start with addressing the questions. And, while we address the questions, I can effectively bring up a snapshot so that we can show you what this looks like on a demo version. But so there were two questions so far that I'm aware of, and if there are others, I can address it. So the first question was, that has come up so far, that's in the Q&A panel, was, is there, let me just bring up the portal snapshot while we address the questions. So the first question was, is Asimily able to address data where the manufacturers are encrypting it, and the kind of data that was given examples for was serial number, a MAC ID, and so on. So to answer that question, the answer for that is, when the manufacturer encrypts the data, certain kinds of information cannot be derived, like the serial number is probably embedded inside the payload, so it's very hard to extract that information. But some other information, like the device type, in many cases, even the model, the manufacturer, the IP, many cases, the operating system, all of those we have been able to derive. And these are some of the things we have been able to do. So there are a variety of techniques we use to do this. Without elaborating on what we really do at the back end, it suffices to say that while there's deep parsing of the packets, which gets us some information, there are other techniques based on profiles and metadata that we also use to get some of this information. So even when the packet is encrypted, and there are certain manufacturers we know encrypt the packet regularly, we have been able to get enough identifying information to identify the manufacturer, the device type, in many cases the model, the IP, the MAC, many times the operating system. But yeah, there are certain things like serial number and firmware version of the device that you won't get if the packet is completely encrypted, for sure. Okay, so that's on that question. And I'll answer the two questions that have come up. And then there are apparently a few more. So I'll keep answering them as they go along, and then some of might be for Patrick. Okay, so the next question that had come up, okay, Q&A here. The next question that had come up was, I can't see it. The next question that had come up was, can Asimily address the risk of devices at procurement? Sorry, not at procurement, for risk of devices even when they are not connected to the network. So the answer to that question is actually twofold. The first part to that question is yes, we can address the risk of devices even when they are not connected. And part of the reason is the way Asimily does risk assessment. So network, like I mentioned, is just one of the elements that we use in understanding the risk. But we also use the MDES tools, which is one of the other factors. If we have some identifying, if we know about the device, we know the operating system, we actually start pulling out the exploit vector to do some additional analysis based on other things we have seen about the device at other places. We also use some of the vulnerability databases that we already have about the device. So even when the device is not connected, you could do a risk assessment of the device. And this is something that's coming very soon. We have actually taken it a few steps ahead so that at procurement, when you are procuring two different devices or two different devices from two different manufacturers, before you actually decide to buy a device and put it in your network, using the Asimily solution, very soon, in the order of the next month or two, you are going to be able to compare the risk of those two devices at procurement and understand, based on all the data we have seen and based on all the parameters of the device, which one potentially might be more risky. And if you choose to still move forward with the more risky device, tell you what is the appropriate level of workarounds or mitigations that you need to enforce to manage the risk of the device in your environment. So while we already allow you to analyze the risk of devices which are not connected, we are just enhancing that a couple of steps further. So you can pretty much use it as part of capital replacement and planning process and capital procurement process. So that's fundamentally something that's very much there and is coming out very soon. So, yes, Priya.
I see a few other questions on the chat box here. The first one is there a link for the slides and the SurveyMonkey for evaluation? Yes. So once you close the once the session is over, you'll see a pop-up on the ACCE website. The recording of this session as well as a PDF of the slide deck along with an evaluation will be made available. The second question is, how does Asimily identify that a device is a medical device rather than a PC?
Okay, so that's a good question. So there is a number of steps we follow. Identifying whether it's a medical device or a PC is actually fairly straightforward. It actually goes even more complicated than that. Even if it's a PC, how do you know if it's a PC used in an IT workstation environment, or if it's a PC used in an IT workstation but it's transmitting PHI, or if it's used in a medical workstation, or if it's just a PC connected to an ultrasound? So there is a lot more granularity to that question than just medical versus IT device. And so, there's a lot of steps we follow. There's a lot of IP we have in the background to actually enable this to happen. Patrick mentioned more than a 99% accuracy, and they have the exact numbers. They did a very thorough evaluation. And the reason we're able to do that, we follow 3 or 4 different broad steps. One is what we call deep parsing, where we go look inside every packet, not just the headers, as some people make it out to be, but really looking at every packet down to the granular detail to see if there's any device-related information within that packet. We also have tons of people like to call device profiles. It's a little more complicated than calling it device profiles, but broadly, for understanding, I would call it device profiles based on profiles of a device that we have observed and trying to correlate that to figure out what kind of device it is. And then we have all this massive amount of information we have collected about the device, by collecting all this information outside of the network, either from documents or our own research. And we have been researching all these devices, so we are able to leverage that to further look at a device and make an intelligent deduction, right? And this is required because on the network, these devices behave strangely. We have seen, for example, BD physics, medical dispensing cabinet. It may appear like an anesthesia machine on the network, or an anesthesia machine might appear like a patient monitor. And so having a deep understanding of medical devices is important to understand which is what. So it's not only the difference between a medical and IT, but understanding what kind of medical device it is also requires a lot of deep analysis, which, like I broadly outlined, we use a few different techniques.
Thank you, Shankar. We have another question for Patrick. Has it been challenging working with your IT department to implement Asimily?
Not really. They're, like I said, they're involved early on in the risk and assessment process, and I think they realized right away how powerful this tool really was. And in the interest of transparency, I'm an army of one. I do all this pretty much by myself, so I need all the help I can get, especially nice, powerful tools to work with. And adding to the fact that we share it with the IT security and networking department, it was a pretty smooth transition.
Thank you, Patrick. We have another question for you. How is MLH compiling software bill of materials for their devices?
Sure. Asimily does a lot of this for us. It does identify devices that are or applications that are being used on the device. And then also at the procurement process, we keep a tight grip on what comes in on those devices. And I do plan to start using our CMMS system to document the SBOM.
Thank you, Patrick. So another question is, will the slides be available after the presentation? Yes, they will be available on the ACCE website. One more question is, with which CMMS does the Asimily software connect presently?
So this is Shankar, so I'll answer that question. So we connect with a number of CMMS systems at Methodist. Can I name the CMMS system you guys use?
Sure.
Yeah. So at Methodist, we are obviously working with AIMS, which we have been working with. We integrate with Nuvolo. We integrate with Accruent. We integrate with Renovo Live. On this, and also on the overall, we integrate with the ServiceNow platform on which some of these are based, and we integrate with the ServiceNow CMDB as well. And then wherever we go, like so, the big three: AIMS, Nuvolo, Accruent, and of course Renovo Live, big four, and then the ServiceNow CMDB. And then what we have also been doing is at some health systems they use things like Mainspring. So we actually have started doing some work there as well. So we effectively, if a health system uses a completely different CMMS system, we do work with the health system and the CMMS provider beyond the ones I mentioned, which we already have out-of-the-box integrations with. We work with the health system and the CMMS player to add those to it. And like I said, we are working on a couple more. The ones I mentioned, we are already deeply partnered with.
Thank you, Shankar. We don't have any other questions, but any last-minute information for the attendees about how they can reach you out or reach your company for a demonstration or any other information that they may need from Asimily or your clients?
Yes. So if you want to know more information from me or Patrick, feel free to reach out. I mean, my email is shankar@asimily.com. shankar@asimily.com. Or if you go to our website, there's an info@asimily.com where you can just reach out to us directly, and then we can provide you the information. Or if you want to see the product, we can show it. Patrick, you can reach out at patrick.duncan@mlh.org. Did I get that email correct, Patrick? Patrick.duncan.
That's correct. Yep.
Yeah. Patrick.duncan@mlh.org. And you can get more information because Methodist has been doing a lot of work around this area. And like you saw, I mean, the cost analysis and everything they did is unique in the sense that they actually did an ROI calculation of what it is to install the system and what benefits they're getting versus what costs they are incurring. So you can get more information from Patrick on that and how they went about the process and how they're currently driving it, which based on our experience is fairly well done, well thought through, and it's a really good program that they have implemented out there at Methodist. So you can reach Patrick at patrick.duncan@mlh.org, and you can reach me at shankar@asimily.com, or you can just email to info@asimily.com, and someone from Asimily will reach out.
Thank you, Shankar. We have another question. Could you provide the Asimily website?
Yes, it's www.asimily.com.
Thank you. We have another chat message from Mark Woodruff at Medimizer, is to contact him regarding a CMMS integration.
Okay, will do. Thank you. So,
thank you, Shankar, and thank you, Patrick, for a great presentation and for sharing this valuable information. I think starting with a cost analysis and a return of investment analysis is really important for HTM departments, and I think that is the right way to go, along with documenting roles and responsibilities when you're using such a great amount of information, because all of this is new information to us. So doing a thorough analysis of who does what really helps in the long term. Again, thank you all for attending this webinar and for sharing your insights, and have a great day. Have a great rest of the HTM week. Thank you.
Thank you, everyone.
Thank you.
Bye.